Now we will start with lesson 3, chapter 12, lesson 3, which talking about determinants and inverse. In this lesson, we will learn how can we find the inverse of a matrix. Now, we know that if we have a number 7, and we know that if we multiply the number 7 with its reciprocal, we get 1. So any number, or the product of a number with its reciprocal, is 1. And 3 with its reciprocal is also 1. And negative 5 with its reciprocal is 1. Here also in matrix we have in matrices we have the same. If you multiply any matrix,
Teacher, its reciprocal should be positive, right? Because the inverse of -5, it is...
no. Reciprocal is 1 over, not the inverse.
Okay.
So if you multiply now any matrix, so as we said here in numbers, the product of any number with its inverse, we get 1. Here also, the product of any matrix with its, the product with any number with its reciprocal is 1. Here, the product of any matrix with its inverse is, we call that identity matrix. Identity, like you have only 1, 1, or 0. So the product of a matrix with its inverse matrix, we have an identity matrix. What is the identity matrix? The identity matrix is like if you multiply a matrix like this one, 3, 1, 2, 1, 4, 1, 7, 7, 5, as an example. You multiply it with an inverse matrix. Later on, we will learn how can we find the inverse matrix. If you multiply them, I told you we get an identity matrix. What is the identity matrix? Look at the first one here. Its dimension is 3 by 3. It is a square matrix, I mean. So also here, it's multiplied by an inverse matrix, which is 3 by 3. So the matrix here, or the identity matrix, will be 3 by 3. How it will be? I will put on the diagonals 1. That's why we call it identity. And the other here, we have a zeros. Like 1, 0, 0, 0, 1, 0, and 0, 0, 1. This is, we called it an identity matrix. Got it? So from this one here, we will know that only the squares matrix only have an inverse. And so not all the matrices have an inverse. Not all the matrices are square. I told you what's the meaning of square. Square, I have a number of columns equal the number of rows. 2 by 2, 3 by 3, 4 by 3. So only for the square matrices, I have an inverse. What is an inverse? We know, or we will learn how can we find it. And if you multiply any matrix with the inverse, you will get an identity matrix. Like a number with its reciprocal, we get 1. The 1 here, we called it an identity matrix, but not reciprocal. I say it is inverse. So the product of a matrix and its multiplicative inverse matrix is the multiplicative identity matrix. The product of a matrix times an inverse is identity matrix. And not all the matrices have inverse matrices. As we said, as I told you, it must be an n by n. It must be a square matrix. Square matrix is a matrix with the same number of rows and columns. while there's a multiplicative identity matrix for any square matrix, and not all square matrices have multiplicative inverse. So if we know that we have n matrices. If we want to say that this matrix is a square, we must have a 2 by 2 or 3 by 3 or n by n. And they told me also not all the square matrices have an inverse. So if you see an 2 by 2 matrix, it doesn't mean it have an inverse. Maybe it didn't have. So we will learn today how can we find the inverse matrix, how can we know if this matrix have an inverse or no, and also how can we find the area of the triangle using this type of using something we call it determinant. So for n by n matrix, the multiplicative identity matrix, as I told you, if I have 2 by 2, I put a number 1 on the diagonal and the others 0. If I have a 3 by 3, I put a number 1 on the diagonals and the other elements will be 0. And if a matrix, you have a matrix A and you have a matrix B, or B, we name it as inverse matrix, like matrix A times its inverse matrix, we get an identity matrix, as we said before. Is it clear?
Yes. Yeah.
Okay.
Yes.
Now, let's first, in this problem here, let's determine if these matrices are inverse or not. How can I know now if these two matrices are inverse or not? By multiplying them. I multiply A times B. If they have an identity matrix I, okay, and if B times A have an identity matrix I will say that matrix A or matrix B will be an inverse of matrix A. So how can I know that if they are inverse? I will multiply A times B. Then I will multiply B times A. If we find that B is an inverse matrix of A and A is an inverse matrix of B, so I will say that matrix A and B are inverses. So let's multiply them here. Here you have matrix A. Matrix B. Now, all of you have your calculator with you now?
Yeah.
Okay.
Yes,
Now,
teacher.
I want you to work with me step by step. First, make shift, mode, alpha mode.
Teacher,
Yes,
teacher, can I just go get my calculator?
yes, please, I'm writing you.
Teacher, we will press alpha and mod in the same time.
Alpha, then mode.
Okay.
And then press on matrix.
Then choose number 6. Yes, but we are waiting, Sarah.
Teacher, I got it.
Yeah. Now, alpha, mode 6.
Teacher, where is 6? I can't find it.
Hello, after you press alpha mode, what is the screen that's shown to you?
1, 2, 3.
Only?
Yeah.
Yes, teacher, me too.
You don't. No, you have the others. You have one from A 1 to 8.
Yeah,
Yeah,
and
I
I
have
chose
from
matrix number 6.
So I think maybe it's you have another button or you don't have the matrix. Okay, the one who have now. Alpha mode number 6. Then on. Then shift 4. Sorry, what's this? No, sorry, wait, okay. I'm sorry. Alpha mode 6. Then before on. Let's start, okay, from the beginning.
Yeah.
1, the first row with the first column. 1 times negative 2 plus 2 times 3 over 2. The second one, 1 times 1 plus 2
Plus 2 times half.
times negative half. Then 3 times negative 2 plus 4 times 3 over 2. 3 times 1 plus 4 times negative half. We multiply them now. 1 times negative 2,
Negative 2.
negative 2 plus 3,
Negative 6.
1.
Like, no,
1.
No.
Then 1, 2 minus 1, 1 minus 1,
0.
0.
0. Negative 6 plus 6,
0.
0.
0.
3 minus 2,
1.
1. So this is an identity matrix. So if you multiply A times matrix B and you get an identity matrix, so I will say that A and B are an inverse matrix.
What do you mean by identity matrix, that we have 1, 0, 0, 1 and
Yes.
like that?
Yes.
Okay. Okay.
And also B times A, you will get an identity matrix. Now let's solve C. Let's see if A and B are identity or no.
I think it is easier than the calculator, but like it's in the calculator more quickly.
Yes, and sometimes if you enter the data wrongly, everything will be wrong.
Yeah. And it will take time like that.
Honestly, with the matrices, I prefer to work by my hand. I don't know why.
Maybe you're interested with it. Yeah. Two times 2, 4.
4.
4 times negative 4, negative 4. 2 times 5, 10.
10.
4 times negative 3, negative 12. 2 times 2, 4, plus minus 2, 2. And 2 times 10, 5, 10. 10 minus 6, 4. Look at them. 0, negative 2, 2, 4. Are they an identity matrix? Are they?
No.
No. No. No.
So I will say A and B are not inverse matrix.
It's like that's it?
Yes.
Teacher,
Yes.
is 0, 1 and 1, 0 like an identity matrix?
No.
Like only
Must
1,
be.
0, 0, 1?
1, 0, 0, 1. Yes.
What about the other one? There's two identities, 1, 0, 0, 1 and the one that is long.
This is a 3 by 3.
The
This-
dimension? Okay. Yeah, this is the dimension, right?
Yes, this is a 3 by 3. 4 by 4, it will be like this.
there is 5 also.
This is also an identity matrix. This one we use it in logic. When I took computer engineering in university, we have 1 and 0. 1 it's mean on, 0 it's mean off.
Teacher, is this they use it in the phones?
In
the phones?
yes, it's in logic.
Yeah, because my dad
They
told me
are working in phone. Yeah.
they took it in engineering. Yeah.
Yes. Okay. So let's continue now. Now here, A and B. For each of the following, are A and B are inverse? This is got it 1. A 1 1 5 4. B it is -4 1 5 -1. Multiplying them now. 1 times -4 is -4.
Yes, plus 5.
1 times 5. Then 1 times 1 is 1 and 1
minus 1.
Then 5 times -4 is 20 and 4 times 5 is positive 20. 5 times 1 is 5 minus 4. Then 1 0 0 1, and this is an identity matrix. Now let's multiply B times A.
Peter, don't erase it. Just a minute.
Yeah.
Yes, okay.
Now B times A.
Teacher, like we're going to say if it's identity or not, we should make both A, B, B, A, not just
Yes,
A, B. Okay.
Now -4 times 1 -4. 1 times 5 is 5. -4 plus 1 is -4. 4 times
1 times 4, which is
-4 5 1 -1 1 1 5 4. Okay, so -4 times 1 and 1 times 5. So -4 times 1 and 1 times 4. Then 5 times 1 is 5. -1 times 5 -5. 5 times 1 is 5 minus 4. So you get 1 0 0 1. And also this is an identity. So I can say now, and there's an A and B are identity matrix.
So teacher, what if AB just is 1 0 0 1, but BA is like 2 5 6 4?
It
It's
can't.
not inverse.
Even if it's AB identity?
Yes.
Yeah.
Okay. Is it clear? This is for how to know if they have inverse or no. Okay, because I want to talk about determinant now.
Yeah, it's clear. Yeah, it's clear,
Okay.
teacher.
Now, every square matrix with a real number elements have a determinant. This determinant, how can we find it? We said it is determinant of A. You have an matrix like this, 3 1 5 0. You say 3 times 0 minus 1 times 5. 3 times 0 minus 1 times 5. So to find the determinant, that is a number associated with the matrix, we multiply A times D minus B times C. This is for the square matrix. A times D minus B times C. This is for the square matrix 2 by 2. Before talking about a 3 by 3, let's first find see how can we find the determinant of 2 by 2. Then we will go back to the determinant of 3 by 3. Let's have this example here. I will say 3 times 5 minus negative 1 times 2. 15 minus negative 1 times 2 is negative 2. So the answer is 17. Now, for the identity matrix, what is its determinant?
0.
0.
0.
Oh, 1.
1.
Oh, it's
Yeah.
1.
That's why we must.
Because
That's
one-
why we must have this order. Sorry.
Because 1 times 1 minus 0 times 0.
Yes.
That's 1. Okay.
If you make it like this, the determinant will be negative, and this is false. That's why I told you the identity matrix have this order: 1, 0, 0, 1, because the determinant must be 1. So this is the determinant for 2 by 2. AB minus, AD minus BC. This is for a 2 by 2 matrix. Now let's talk about 3 by 3. For a 3 by 3 matrix, is it like this: A1, B1, C1, A2, B2, C2, A3, B3, C3. The first step, you have to copy this one, which is A1, A1, B1, A2, B2, and A3, B3. Copy these two numbers and write them here. Then after that, look here, make these diagonals. Let's see, let's do it now.
I think the dimension 3 times 3 is a little complicated.
Yes. And they hated them. If you have this matrix here now, I told you, you have to copy. So the first step, copy the first two columns, which is 3, 1, 5, 0, 1, 3. Copy them. These two, copy them. This is the first step. Then, bring now, like this one here, diagonals. Start like this. This is the first one. Must be passing it by number 3, by the way, okay? Is it 3, 0, 2, 1, 2, 1, 4, 5, 3? Multiply them now. 3 times 0 times 2 plus 1 times 2 times 1 plus 4 times 5 times 3. 0 plus 2 plus 4 times 5, 20 times 3, 60. So this is the first part.
Teacher, what about 3 and 0?
About what?
3 and 0.
No,
The other.
keep them,
Can
keep
you
them.
make it 3 0?
No, لسه ما عملناش. استنى شوي. Then go from here. No, no.
Teacher, isn't it supposed to be 1 multiplied by 0 multiplied by 4?
Yeah. It's like this now. You start from 1, passing through 0, ending with 4. From 3, passing with 2, ending with 3. And from 2, 5, 1. After that, let's now multiply them. 1 times 0 times 4 plus 3 times 2 times 3 plus 2 times 5 times 1. 0 plus 9, 18 plus 10, 28. Then after that, subtract 62 minus 28, and you will find the determinant as 34. So the determinant of this 3 by 3 matrix is 34. I will repeat. Here, moving this down here. Let's start. So copy the first 2 columns, then make diagonals. 3, 0, 2, 1, 2, 1, 4, 5, 3. You must end here. Then start from the bottom now. 1, 0, 4. So let's remove the 3 greens here. Then 0, 1, 4. 3, 2, 3. And 2, 5, 1. Multiply them. Then after that, subtracting them. Don't forget, you must up